Okay, we're going to start talking about measures of variation. They're also called measures of spread and measures of dispersion. So these all mean essentially the same thing. A set of data exhibits variation if all the data are not the same value. In other words, if all the values are identical, there is no variation. And so what variation measures is the degree of homogeneity between the values. I'm going to give you an example here. Let's say this is last semester and you are about to take statistics, this statistics class, and you want a C. Let's say that you really just don't really care even about learning anything. You just want to get that C, okay, so that you can pass the class and not have to take it again. So some instructors post their grades, say, on their door. So you wander up to the math department and look for grades, and you find these two teachers, Mr. A and Mrs. B, who teach statistics, and these are the grades that they posted for last semester. Of course, these lists would be much longer, but for the sake of lecture, these are a short list. So what we want to do is come up with a rule with how do we choose which teacher that we want, okay? How do we choose the teacher that we want? And so at this point, I often get different responses, like the mode or the median, or to look at how the variation in the values, okay? And the truth is, none of those things really matter except the mean, okay? So what we really want to look at for these grades are the mean. I'll try to give you some examples of why it wouldn't be other things. Some people say, oh, it should be the mode, and I ask, why the mode? Like, what's your criteria? And they say, oh, the one that has the highest value that occurs most often. And so, as you can see in these, with these two values, the mode is 76 here. In fact, we can write that here. The mode is 76 in both of these cases. But if I were to give you one that had, say, a mode of the highest mode, so this one is going to have, say, a mode of 77, but I could have all the other grades as 10, a 10, well, that wouldn't make it the mode anymore, say a 10, 11, a 12, et cetera, et cetera. And you can see that this would not be the best class to take. So it's not about the mode. It's not about the median either. Although you can see, I set this up so you can find the median easily. Remember, if you put your data in order, the median is the center value. So in this case, the median would be also 76. But we really don't want to, well, that's good practice, but we really don't want to look at these values either. It's also not about variation. It really is just about the mean. You want to take the class that gives the highest grade on average, no matter what it is, okay? So you always want to go with the class that gives the highest mean on average. And so let's calculate the mean for Mr. A. And if you do that, what you're going to find out is that the mean is equal to 73 for Mr. A, okay? But it also turns out that the mean for Mrs. B is also 73. So clearly, though, if you want to see, you can see which class you would pick. So you should have a gut instinct that you probably want to pick Mr. A, but if either one of these had had a higher mean, you would go with that one, okay? So you would not want to go with Mrs. B. Why? Because this set of grades is more variable. There's more variability, okay? And the mean is just not sensitive to this. So X bar is not sensitive to variability, okay? And so this has more variability in it, okay? Let me put it to this here, okay? So here you can see that Mr. A, pretty much, if you take Mr. A, you're going to get a C. Now, of course, you're not going to get an A or a B either. For Mr. B, though, you can get an A in the class, but you can also be one of these unfortunate people that fails the class. So there's a lot more risk here in taking Mrs. B versus Mr. A. So once we've already established that the means are the same, then it looks like this is going to be. And of course, remember, the mean is the better measure here. You see how the mean and the median are very, very close. Remember, we talked about the fact that the mean is going to be better, especially for grades, which should be intuitive for you. Now, there is variation in everything made by humans and that occurs in nature. We don't expect any two snowflakes to look the same. If you're looking at almost anything, things aren't going to be perfectly identical, okay? But there is the variation that we expect and the variation that that we do not expect, and we'll talk about that in a minute. So the less variation we have, the more consistency there is. Okay. And this is important. I like to explain this in a number of different ways. If you can picture for a minute what you would get if you, say, drive up to a McDonald's and get a quarter pounder, you should have even if you don't eat at McDonald's, you should have a good feel for what you would get when at the drive-in window, okay? You're supposed to have about a quarter pound of meat on that hamburger. This isn't about how much meat you get on average, because if it was, then one time you could get a whole pound of meat and luck out, and then another time you could get a very little bit of meat, and it would always be risky going there. What's more important is the consistency, that you get the same amount of meat every single time you go. And so that's what we're interested in. For example, let's say I wear a pair of size 8 Levi's, okay? Now, of course, not every pair of Levi's is going to be identical, but they might be faded a little bit differently, or the sewing might not be absolutely identical. That's true. But if I trust Levi's, then after wearing their product for a while, I should be able to go into, say, a Kohl's and grab a pair of size 8 Levi's off the rack and take them home without trying them on, because I pretty much trust the consistency in their product. Okay. Of course, no two jeans are exactly the same, but if I all of a sudden brought home a pair of jeans where one leg is an inch longer than the other, then of course I would cease to buy their product, because then it becomes a little too risky. Another place that we might see that is, say, in quality control, where we are, say, filling 12-ounce bottles of Gatorade, okay? Now, do you think that every bottle of Gatorade has exactly 12 ounces? And the answer is no. So you might have, say, 12.001 ounces, and another bottle might have 11.897 ounces, et cetera, but you're going to expect some variability. Most bottles don't have exactly 12 ounces, but they have right around 12 ounces. And so when they're filling those bottles with the machinery, there's going to be someone that comes around, say, I'm just making something up, every hour to test the bottles, to measure the contents of the bottles, and they're going to make sure that they're right around 12 ounces. Now, if all of a sudden they have an 8-ounce bottle of Gatorade, then that alerts them that there may be some problems with the machinery, and they may need to go adjust it. So variation is either inherent, that natural variation that we expect, or to a product, or it can be attributed to something that's not considered random, like I showed you that 8, maybe the machinery is not working, etc. So this is going to be kind of an important topic here. What does variability tell us about the mean? Okay, well, the more homogeneous the data, the better the mean is going to represent a typical data value. Remember, the mean is supposed to represent a typical data value. So if you go back up here to Mr. A, you see that the mean is 73, And it's doing a much better job at describing Mr. A's class, right? People at Mr. A's class pretty much get 70s, and that's what the mean tells us. Whereas when there's more variability, the mean isn't really as good at showing us what a typical data value looks like. In fact, we talked about this already. If everybody, say in the class, gets a 90 on the next exam, then of course the mean would be 90, and the mean would be telling us exactly what's going on in the class. So if all the data values are identical, okay, which is what I just said, that mean is going to provide perfect information. Okay? In other words, as we said before, that if everybody gets a 90, the mean tells us exactly what's going on, which would be a 90, okay? And if all the values are identical, then we say there's no variation, and the numerical value that we give to it is 0, okay? So we have 0 variation in this case, okay? And then it just goes up from there. So measures of variation are always positive, okay? So anything above 0 indicates some variation, okay? Now, we're going to start off with the range, which is a measure of variation, okay? This measure comes from taking the highest value minus the lowest value. I wouldn't be giving you this formula since it's pretty straightforward. And as you can see, it's very easy to compute, okay? But it's also easy to understand why people might use it, okay? So it's easy to compute and understand, right? Because what's the range? It's going to be the highest minus the lowest. So if all the values are identical, the maximum and the minimum value will be the same, and you'll get a variation of 0. The more spread out your values are, the bigger that range is going to be. So it makes sense, okay? Now, what is the range for our accident data that we had been talking about before? Well, the range then is going to be the highest value, which you can see is going to be 27, minus the lowest value, which is right there next to it, 4, to get a range of 23, okay? Now, I want you to consider these as 2 separate data sets right here, the top and the bottom. Hopefully you can see that the top data set is very consistent compared to the second data set. Pretty much these are all 20s except for one value. So there's a lot more consistency in the top data set. What I'd like to do is find the range for this top data set. And as you can see, you can probably do that in your head. It would be 20 minus 1, which is 19 for this data set, okay? Now let's find the range for the bottom data set here, and you'll find that it's also equal to 19. So according to the range, there is very little difference between these 2 data sets, when clearly that's incorrect, right? There definitely is a difference in variation here, okay? So these are different, and let me see. And so the range is just doing a very horrible job of checking, of distinguishing between these 2. That's because the range is very sensitive to extreme values. I hope you can see that. Let me move this over a little bit. Oops, yeah. It's very sensitive to extreme values. And it only uses 2 values in its calculation. Its calculation. In other words, it just uses the highest and the lowest value, but ignores everything that's going on in between here, you know? So it only uses 2 of the numbers, and if they're extreme, it's really gonna mess everything up. So the range is really a very crude measure. And so you want to be careful when you see people using the range. It's really not a good measure of variation. It kind of ignores everything. We're really going to prefer a measure, and we'll talk about that later on, that takes every value into consideration. Okay, so that's our first measure, and we'll be talking a lot more about that.